This video is a very brief overview of re-expressing data. This is not a topic that we get into a lot of detail in this course. So looking at this data set, I can see, particularly with my, well actually with both, but certainly because I've used fences to identify outliers, I've got a whole bunch of outliers going on here. And I can see that as well looking at my histogram. I wouldn't be able to tell which ones are outliers, but I could certainly see that this is a very skewed distribution. And therefore it's going to be kind of difficult for me to determine the center of this, because I just don't know. I would just be guessing. There's so much space here. And so what we'd like to do is to possibly re-express this data, because in the next several videos we'll learn about how great the normal model is. That was a really bad normal model. But essentially the normal model is the standard bell curve that we're all used to. And if we're able to somehow re-express our data so that it fits that normal model, it just opens up a whole world of things that we can do. So notice this histogram shows the exact same data that I had on the last slide, but how did I get it to look like that? Well, I took the logarithm of each data value, and notice now it looks nice and pretty, fairly symmetrical. It kind of fits the normal model, and that brings joy to a statistician's heart. The thing you just need to watch out for here is that you always mention that we're talking about log. So if I was finding the center wouldn't be, 6.5 or whatever. It would be the median log salary is, etc. So always make sure that you're using that logarithm or whichever function you used to re-express your data. There's no hard and fast rules for how to re-express data, but in general, if you have data that is skewed right, it is best to use the log function, the natural log function, or the inverse function. And if it is skewed left, it is best to use the squared function, because that creates all positive values when we square something. And again, in the real world, this is done just using technology. And again, this is just one more example for you to look at as to how it might be helpful to re-express our data with logarithmic re-expression. I can't even tell what's going on down here, but if I use the logarithmic re-expression, I can see a little bit more about what's going on. Again, nothing can really be learned from this graph, whereas if I look at it over here, now I can start to look at where the medians are for these, how symmetric the distributions are if we have outliers, etc.